Now let us see least square approximation. Least square approximation. What is the least square approximation? This approximation is used. This approximation is used to approximate a function f of x, which may be given in tabular form. Which may be given in tabular form. Which may be given in tabular form means table values x versus f of xi. X versus f of xi, tabular form. Nothing but xi versus fi, I equal to 1 to n, or the function is known explicitly, or the function is known explicitly. Function is known explicitly means the function will be given f of x equal to x square or x cube, like that. So function is known, or function is known in terms of tabular form, that is x values versus function values. Now in this case means in this least square approximation we can use, or we use the L2 norm, which is also called L2 norm, or L2 norm, or least square norm, or square norm. One can say it is square norm. Last class, you know what is square norm. The best approximation in the least square sense, the best approximation for what? For the function f of x. The best approximation in the least square sense, that means in the least square approximation, least square sense is defined as that for which the constants ci, for which the arbitrary constants ci, I equals to 0, 1, 2 and so on, and you know what is approximation function, c1 c0 into phi naught plus c1 into phi 1 plus cn into phi n. In that the arbitrary constant ci we have to determine, are determined so that the aggregate of weight function into error square, over a given domain, capital D, is as small as possible, where w of x or the positive greater than 0, or the weight function, See what is the meaning of this statement? Least square, we have to apply least square approximation. What is the error here? Error is f of x minus p of x, right? F of x minus p of x. And what is this one? You know, f of x minus, what is this, is c0 phi naught plus c1 phi 1 and so on, cn phi n, and I have to minimize this one. Minimize this error. So the, what is this one? E square means what? Error square. This is the error. I have to take square for this error. The square of the error should be minimum, as small as possible. It must be minimum. Okay, where w of x, the weight functions are chosen as a product of this e square, w of x. One can say w of x, mostly one can say 1 if it is not given in the problem. Okay, this is least square approximation. Now see how it is implemented and problematically. For the function, for the functions, for the functions whose values are given at n plus 1 point, given at n plus 1 points, x1 x2 and so on, xn means what? At x0 f0 is given, at x1 f1 is given, at xn fn is given, tabular points are given. We have one expression I which depends on c0 c1 and so on cn is equal to summation k equal to 0 to n, the weight functions w of xk multiplied by the original function f of x at the point k minus, previously I have written the ck into the approximation phi I xk I equal to 0 to n for this whole square, w into e square, e value is what here? Here e equal to what? F of xk minus summation ck into phi I xk. This is ei. Okay, this is the error, and error square we are considered is minimum. This is equal to this I should be minimum. I value is what? Weight function into error square. Okay, and for functions this is the formula for what? At n plus 1 data points for functions which are continuous, now not discrete, which are continuous, that means data points are not given directly, the function is given, data points are not given, that is the function is which are continuous on closed AB, and are given explicitly, we have means function is given, f of x is given something x cube minus x square like that. Okay, we have what is I then for continuous, this is discrete case for the points with the data is given x versus f, this is the formula. If the function is given, then what is the formula? Integral a to b over the domain a to b, the weight function multiplied by f of x minus summation I equal to 0 to n ci into phi ix, this whole square dx, this I value should be minimum. I have to minimize this I. Okay, and the coordinate functions, what are these phi? These are the coordinate functions. So the coordinate functions theory is somewhat hard, but problems will be very easy in this least square approximation. The coordinate functions phi ix are usually chosen as phi I x equal to x to the power of I equal to 0 1 2 and so on n. Already I told you this, x power I, and w of x weight function is taken as 1 if it is not given in the problem, now to minimize this I or this I, for maxima and minima, the necessary conditions are what? The necessary conditions for minimum, minimize what? I are, what are those? The partial derivative of I with respect to arbitrary constants equal to 0, I equal to 0 1 2 and up to n, this gives what? This gives how many equations totally? 0 to n means n plus 1 equations. This gives a system of n plus 1 linear equations. linear equations in n plus 1 unknowns. In n plus 1 unknowns, what the unknowns? C0, C1 and so on, Cn. Okay, these equations are called, these are very important, these equations are called normal equations. These equations are called normal equations. Normal equations. Now, so what are the normal equations? If I take a differentiation of this, therefore dou I by dou Ci equal to 0 implies, okay, for the discrete case, let me consider summation k equal to 0 to n w of xk, and this is whole square na, so f of xk minus summation I equal to 0 to n ci into phi I of x k whole square. Whole square derivative with respect to ca means this 2 comes here, this 2 comes here, right, into this c j, let us take generalization cj, so phi j will come here, phi j of xk equal to 0. This is from where j equal to 0 to n, j equal to 0 to n, or for integration, or if I is in terms of integration, then what is this is dou e by dou j cj equal to 0 implies, instead of summation you will get integral a to b w of x, this f of x minus summation ci phi I of x, this I equal to 0 to n, and what is the derivative with respect to j? Cj derivative phi j of x dx equal to 0. This is j equal to 0 to n. Okay, now one can cancel this 2 and this part, this bracket function equal to 0 or this integrating function is equal to 0. This gives how many equations? N plus 1 equations, which are called normal equations, which are called normal equations. This is about theory only. Problems are very simple. I will explain how to write these normal equations in the problem. Now see the first problem. Obtain a linear polynomial, approximation, to the function f of x equal to x cube on the interval 0 1, using least squares approximation, with the weight function w of x equal to 1, Solution. See this problem, the function is given here, that means function is known explicitly, f of x equal to x cube defined on what interval? 0 comma 1, so it is continuous case. First point. Second point is what? I have to obtain what one? We have to find what approximation? Linear polynomial approximation. We have to find linear polynomial. Linear polynomial means what? Straight line. We have to find linear polynomial approximation to f of x, right? Therefore, consider, now we have to assume this, consider the linear polynomial. What is that linear polynomial? P of x equal to c naught x plus c1, equation 1. Okay, where c0 and c1 are arbitrary parameters. c0 and c1 are class lo c0 and c1 are arbitrary parameters. Okay, Now this one is where C1 and C2. Now how to write normal equations? See, first thing, to write normal equations, first let us write what we have to minimize in this one using least square approximation. Using least square approximation, we have to minimize what? We have to minimize I of what? How many arbitrary constants? Only two arbitrary constants. And what is the interval a to b? W of x. And how to write this? Write the function f of x minus the approximate polynomial whole square dx. Approximate polynomial whole square dx. Did you understand what is that? I equal to weight function and original function f of x minus the approximate function, this one whole square, least square means this whole square dx. To minimize I, what are the necessary conditions? Now let me substitute first. This implies I of c0 c1 is equal to integral a to b means 0 to 1, w of x means 1, and what is this? F of x minus p of x, this one whole square dx, right? And what is f of x is given as x cube function is given, and what is this function? This is c0 x plus c1, this whole square dx. I have to minimize this function. For minimum the necessary conditions are, what are the first one? Dou I by dou c0 equal to 0. Another one is what? With I partial derivatives with respect to arbitrary constant c0 and c1 is 0. First with respect to c0 for this. So first one is what? 2 into 0 to 1 x cube minus c0 x minus c1. Okay, and with respect to c0 means what is its quotient? Minus x dx equal to 0, isn't it, right? And the next one, one can write, one can do similarly. You can take the integration of this, then simplify. You can simplify this also, but this is better, I think, right? This is equal to, with respect to c1, this is 2 into integral 0 to 1 x cube minus c0 x minus c1, and what is c1 derivative? Minus 1 dx equal to 0. So therefore from the first expression what I'm getting, this is anyway this 2 cancel and negative is also cancelled. So what are the remaining expressions? This is x into this integral 0 to 1 x power 4 minus c0 x square, right? Okay, minus 2 in both sides, both are cancelled. Minus 2 c0 x power 4 minus c0 x square minus c1 x minus c1. Now after taking integration and substituting the limits, the first expression dou u by dou c0 equal to 0 gives minus 2 by 5 plus 2 by 3 c0 plus c1 equals to 0, and dou I by dou c1 equals to 0 gives the expression minus 1 by 2 plus c0 plus 2 c1 equals to 0. Okay, solving these two equations, c0 value is 9 by 10 and the c1 value is minus 1 by 5. Therefore the required linear approximation is, what is that? P of x, linear approximation to the function f of x equal to x cube is p of x equal to what? c0 9 by 10x plus c1 minus 1 by 5. This is equal to 9x minus 2 whole by 10. This is the approximation. Okay, and one can say if you want any value The simple, that's enough. This is the least square approximation to the function f of x equal to x cube. F of x equal to x cube. Next question is, obtain the least square polynomial approximation. Least squares polynomial approximation of degree 2 for f of x equal to x to the power of 1 by 2 root x on 0 comma 1 solution. Okay, solution. Let f, okay, what is the given? F of x equal to x to the power of 1 by 2 on the function 0 1, means function is given explicitly. Consider a polynomial of degree 2 simply called parabola p of x equal to c0 plus c1x plus c2x square. Okay, this is equation 1. And since weight function is not given, take weight function is not given, w of x as 1. Okay, using least square principle, using least square approximation, we have to minimize the value, we have to minimize the function I of how many arbitrary constants? C0, C1 and C2, 3 arbitrary constants. Since it is continuous case, a to b, the weight function multiplied by the error. What is the error? The original function minus the approximate function whole square dx. I have to minimize this. This implies I of C0, C1, C2 is equal to integral, the domain is 0 to 1, weight function is 1, and what is the function? This is f of x is x to the power of minus 1 by 2, and p of x is what? Minus c0 c1x minus c2 x square dx. I have to minimize this, right? This is equation 2. For minimum, you know the necessary conditions. For minimum, the necessary conditions are, first one is what? Dou a by dou c not equal to 0, first one. Second one is what? Dou a by dou c1 equal to 0. Third one is what? Dou I by dou c2 equal to 0. So the first one, dou I by dou c not equal to 0, means minus 2 integral 0 to 1. This is x to the power of 1 by 2. The function will be there, c2 x square dx. Why this is? c0 derivative is minus 1 and whole square 2 comes here, equal to 0. Coming to dou I by dou c1, simple integration. This is c0 minus c1x minus c2 x square. And what is c1 derivative? c1 derivative minus x. So minus already included here. So you will get x here 0, right? And the third one, this is minus 2 into 0 to 1, x to the power of 1 by 2 minus c1 minus c1x minus c2 x square. And what is the c2 derivative? Minus x square, minus already included starting, x square dx equal to 0. Okay, so after integration, you take the integration. I am not doing here. After integration and substituting the limits, we get c0 plus c1 by 2 plus c2 by 3 equal to 2 by 3. First expression gives this with this one. Second one, c0 by 2, c1 by 3, c2 by 4 equal to 2 by 5. And third expression, c0 by 3 plus c1 by 4 plus c2 by 5 equal to 2 by 7. Okay, solving this, c0, we are getting c0 equal to 6 by 35 C1 equal to 48 by 35 and C2 equal to minus 20 by 35. Minus 25 35. Therefore the second degree polynomial approximation is what? P of x equal to C naught, totally 1 by 35 is common, C naught 6 plus 48x minus 20x square. This is second degree approximation. Okay, now for straight line and for parabola, let us derive the normal equations directly. Okay, now next question, derive the least squares straight line and quadratic fits for the discrete data. Now for the discrete data, what is discrete data means? Table is given, x values versus y f function values 0 to n, 0 to capital N, one can say. Or the question may be derive the normal equations for straight line and parabola means quadratic expression, parabola using least square principles, for the data xi comma fi I equal to 0 to n. Solution. Okay, first case straight line. You have to remember these normal equations directly. It's easy to remember. Straight line, let P of x equal to C naught plus C1x, equation 1, be the straight line approximation or linear approximation. Straight line approximation. Then we have what we have to minimize. Then we have I of C naught comma C1, only two arbitrary constants are there. Summation, instead of integration, discrete data, summation will be there. W of x value is 1, so f of xi minus p of xi, square. It should be minimum. This should be minimum, right? W of x value is what? 1 here. So this implies what is I C naught C1 is equal to, now this is equal to sigma I equal to 0 to n. I don't know what is the function, so f of xi as usual minus, what is this one? Minus C naught minus C1 xi whole square. Then for minimum, the necessary conditions are, for minimum the necessary conditions are, what is the first one? Dou I by dou C naught equal to 0. Second one, dou I by dou C1 equal to 0. Coming to first one, you will get first 2 into whole square is there now, so I equal to 0 to n. This is function as usual minus C naught minus C1 xi whole square, 2 comes here, and what is C naught derivative? Minus 1, so minus I am including here, minus 1 equal to 0. And second one, 2 into I equal to 0 to n. This is f of xi minus C naught minus C1 xi. And what is C1 derivative? Minus xi. Minus I have written here, xi here. So finally, after simplification, this minus 2 I can neglect. Okay. Then what are the normal equations becomes? See, normal equations becomes, keep f terms on the left side. I equal to 0 to n equal to take these terms onto the right side. So C naught is the constant, so 1 I equal to 0 to n plus C1 into summation is only for I terms, so keep I terms within the summation. Coming to second, this take this one, this multiplication on f terms on the left side, so I equal to 0 to n, this xi into fi, xi into f of xi equal to C naught into summation xi I equal to 0 to n plus C1 into summation xi square 0 to n xi square, right? So one can, and what is this summation 1 sigma 1 I equal to 0 to n means what? I equal to 0 to n means 1 plus 1 plus 1 plus up to plus 1. How many times? N plus 1 times. 0 to n means n plus 1 times. So this value is what? N plus 1. N plus 1. So the simplified equations are, therefore the normal equations for straight line. What is a straight line? Normal equations for straight line. F of x equal to C naught plus C1x r. In place of P of x I have written f of x. So how to write this? R, first one, take the summation on both sides of this equation equal to C naught into n plus 1, right? N plus 1 summation 1 n plus 1 into C naught plus C1 into summation x. Summation is only for x terms. This is the first equation, and one can write, if I put I equal to 0 to n means you replace x by xi and put summation 0 to n. Take the summation on both sides of this expression. C naught quotient is 1, multiplying on both sides 1, this expression, take summation. Coming to second normal equation, one can say this is normal equation for C naught. How to write normal equation for C naught? For the function f of x equal to C naught plus C1x. See the C naught quotient 1. So multiply this expression by 1 and take the summation, directly you will get this expression. Next one. Normal equation for C naught is C1 is obtained. What is its quotient? X. Multiply this entire equation, the given equation, by x, that is C naught x plus C1 x square. Multiply this expression by x on both sides, then take the summation here, summation here, summation here. If you want items, you can put I, xi into xi. Here I equal to 0 to n, I equal to 0 to n. This is normal equation for C1. That's it. These are normal equations. So how to solve these two equations for C naught and C1. That's it. Lastly, substitute in the function. Then how to solve in problems? In problems you will get these values, x versus f, x naught, x1, x2 and so on, corresponding values f naught, f1, f2, right? And what are the required values? See, I'm showing summation x. Summation means this total summation, sigma f is required, sigma f. Next one is what? N plus 1 means length of the data, it is already. Sigma xi is also required, so sigma x, nothing but sigma xi. Another one is what? Xi square is required, so you write x square. For x, write x square. Some values will be here and get sigma x square value, right? Another one, summation xi already there. Next one is what is required? X into f, this value, x into f. So take the product of x and f right here, and here you find x into f value. Substitute all these values in these two expressions and solve them for C naught and C1 and substitute in the straight line expression. These two are the normal equations for the straight line. Now normal equations for parabola. Normal equations for parabola or second degree polynomial. Okay, let the second degree approximation, polynomial approximation being p of x equal to c0 plus c1x plus c2x square for the data. What is the data? xi versus fi, 0 to n, so we have to minimize what? We have to minimize I c0 c1 c2 equal to summation. Data points are given, so I equal to 0 to n, the function f of x minus this quadratic polynomial c0 minus c1x minus c2x square whole square dx. Okay, now then therefore for minimum, what are the necessary conditions? For minimum we have dou I by dou c0 equal to 0, dou I by dou c1 equal to 0, dou I by dou c2 equal to 0, after taking differentiation, therefore the normal equations for parabola are, see how to write. What is the approximation? The original function is here f of x, and what is the approximation? c1 c0 c1x c2 x square, c0 plus c1x plus c2x square. First one is what? c0. What is c0 coefficient? 1. Multiply this entire equation by 1. That means write f of x equal to c0 plus c1x plus c2x square. Then take the summation, sigma, and here also you will get sigma. 1 means what? N plus 1. Sigma 1 means what? N plus 1 over. This is the normal equation for the straight line, and if you want to write I, then write like this: I equal to 0 to n xi, I equal to 0 to n xi. First equation. This is what? This is normal equation for c0. And coming to second one, what is c1? I have to write for c1. What is its coefficient? X. Multiply this entire equation by x. Then what is this? Is x into f of x equal to c0 into x plus c1 into x square plus c2 into x cube. Then take the summation. Then assign I values 0 to n. xi, this one, xi. I is from 0 to n. I is from 0 to n. This is what? This is normal equation for c1. And the last one, what is that last one? c2. What is its coefficient? X square. Multiply this entire equation by x square. So x square into f of x equal to c0 into x square plus c1 into x cube plus c2 into x power 4. Then take the summation. Summation is only for x values. Summation, right? And summation is from I equal to 0 to n xi. Here also I. 0 to n xi, 0 to n xi, 0 to n xi. This is normal equation for c2. Solve these three normal equations for c0, c1, c2. That's it. For the best fit. Best fit in the sense of least square. Okay, and what are the required values? If tabular values will be given for you, x, this is x0, x1, x2 and so on, f0, f1, f2 and so on. What are the required values in the three normal equations? X square is required, x cube is required, x power 4 is required, right? Next one, what are the required? X into f value required, x square into f value required, all these values required. So compute all these values from the table and find sigma x, sigma f, sigma x square, summation. It is take the sum of all these, sigma x power 4, sigma x f value, and a sigma x square f value. Find all these values and substitute all these values in the normal equations, get c0, c1, c2. Okay, now take one problem in discrete case. Obtain the least square straight line fit to the data x versus function of x is given 0.2, 0.4, 0.6, 0.8, 1, 0.447, 0.632, 0.775, 0.894, and 1 and 1. Okay, solution. Let the straight line be what is that? P of x equal to c0 plus c1x, equation 1. Using least square approximation principle, the normal equations for 1 r, okay, what are the functions? One can say this is f of x is approximated by p of x. This is approximate symbol. F of x is approximated by p of x. What are the normal equations? Multiply this equation. For your idea, I am giving this f of x equal to what? c0 plus c1x. In place of p of x, I have written f of x. So what are the normal equations? First take the summation. First one, summation f of x equal to n plus 1 into c0, plus c1 into summation x. First equation, this is equation 2. Second equation is what? Multiplied by x, c1 quotient. So x into f of x equal to c0 into summation x plus c1 into summation x square. This is equation 3. So find all the values x, f. What are the required values? Form a table. 0.2, 0.4, 0.6, 0.8, 1, and sigma x, this is 3, and f values 0.447, 0.632, 0.775, 0.894, 1, and this is sigma f value 3.748. And what are the next required values? X square is the required value, and next function is what? Required is x into f. So x f is required. So x square value 0.04, 0.16, 0.36, 0.64, and 1, and the sigma x square value is its value is 2.2. and you find, take the product of x into f, right here, this is 1 anyway, and the sigma x f value 2.5224. So substitute in this equations. Equation 2 implies this is 3.748 equal to, what is the length of the data? 1, 2, 3, 4, 5. 1 2 3 4 5. Actually one can write not here n means length. Let me write this one. This is length n only. N means what is the length of the data? 1 2 3 4 5. Previously I is from 0 to n we have considered, remember, 0 to n. So how many points? N plus 1 data points are there. So what is this? x0, x1, x2, x3, x4. Okay, anyway n always stands for length of the data. What is n value here? N equal to 5. So this value 5c0 plus sigma x, this is 3c1, and equation 3 implies sigma fx, this is 2.5224 equal to c0 sigma x, that is 3c0 plus x square c1, 2.2 c1. Solving c0 equal to 0.3392 and c1 equal to 0.684. Therefore required straight line approximation is p of x equal to c0 0.3392 minus plus 0.684x. This is required approximation. And what is the least square? Let me write here, and the least squares error, is what? Least square error is what? From the function f of xi minus c0 minus c1 xi. Do you remember, right? Or this one, this whole square. I equal to, from where to where? How many values? I equal to one can write 0 to n values, and therefore this is equal to first one, f of x. If I substitute 1 by 1 values, y equal to 0, f of x0 minus c0 plus c1 x0, isn't it? This one whole square plus f of x1 minus c0 plus c1 x1 whole square, and so on. Lastly, what? F of n value is what here? N value 4. So f of x4 minus c0 plus c1 x1 x4, this whole square. If I substitute all the values, you know what is f of x0. Now what is c0? Let me write in a simple manner. This is I equal to 0 to 4. This f of xi, you know all these values. What is c0? 0.3392 minus 0.684x, this whole square. If I substitute this, I equal to 0 term plus I equal to 1 term plus 2 term plus 3 plus 4th term. Substitute f of x0 and this value. What is this? xi. If I substitute all these and simplifying, the least square error is 0.00245. This is the error between the function and the approximation. Now next problem. Find the least squares approximation. Find the least square approximation of second degree for the discrete data. For the discrete data x versus f of x -2 -1 0 1 2 15 1 1 3 19. Okay, solution. Let the second degree polynomial be p of x equal to c0 plus c1x plus c2x square. Equation 1, where f of x is approximated to p of x. Okay, For equation 1, the normal equations using least square principle are what is that? How to write? What is the equation now? What is approximation? F of x equal to c naught plus c1x plus c2x square. In place of p of x, write f of x. So what are the normal equations? First one, take what is c naught quotient 1 multiplied by 1 and take the summation. So summation f of x equal to this value n plus 1. If you start with x naught, okay. One I will write here: x naught, x1, x2, x3, x4. 0 to 4 means, then you consider n plus 1. If you start with x1, then this will be 5 directly. N plus 1 c naught plus c1 into sigma x plus c2 into sigma x square. Next one is what? This is normal equation for c1 is what? What is this quotient? X. Multiply this expression by x, sigma x into f of x on both sides. C naught into x, so sigma x. C2 into x square, so sigma x square. C naught c1 and c2 into x square into x cube sigma. This is normal equation for c1. Coming to third one, c2 expression. C2, what is its quotient? X square multiplied by x square into f of x, c naught into x square plus c1 into x cube plus c2 into x power 4. Then assign summation for x terms. These are the normal equations. Now let us find all the values. What are the required values here? Sigma f of x, sigma x into f of x, x square. Sigma x is required, x square, x cube, x power 4. These are all required. So form a table. What is the table now? X versus f. X square is required, x cube is required, x power 4 is required, right? And x into f is required. Next one, x square into f is also required. Put all these values over the table. This is -2, -1, 0, 1, 2. F values 15, 1, 1, 3, 19. X square 4, 1, 0, 1, 4. X cube 8, 1, -1, 0, 1, 4. X power 4 16, 1, 0, 1, 16. X into f -30, -1, 0, 3, 38. X square into f 60, 1, 0, 4. Sorry, x square into f 3. This is 76. Now find all the summation. What is the sigma x? Sigma x is what? 0. And this is sigma f. Sigma f value 39. Next, sigma x square 10. Sigma x cube 0. Sigma x power 4. This is 34. And sigma x into f, this is 10. And lastly, sigma x square into f 140. Therefore normal equations becomes, after substituting all these values, you will get normal equations as 5 c naught plus 10 c2 equal to 39. And next equation 10 c1 equal to 10. Next one 10 c naught plus 34 c2 equal to 140. Solving these equations, what we are getting? C naught value -37 by 35, c1 value 1 and c2 value 31 by 7. Therefore the second degree polynomial approximation is p of x equal to, okay, c naught What is C naught? Minus 37 by 35 C naught plus C1x plus C2x square, 31 by 7 x square. If I take 1 by 35 as LCM, this is minus 37 plus 35x plus 155 x square. This is second degree polynomial approximation by using least square method. Now consider the another problem. This is different one. Use the method of least squares. Use the method of least squares to fit the curve f of x equal to c naught x plus c1 by root x. So this is not straight line, not parabola, somewhat different. For the data x versus f, 0.2, 0.3, 0.5, 1, 2, 16, 14, 11, 6, 3. Find the least square error. Find the least square error. Okay, this is the problem. Since the given curve is not f of x is what? C naught x plus c1 by under root x. This is not straight line, not parabola. So I have to derive the normal equations for this expression using least squares. Using least squares, we have to minimize what? We have to minimize I, c naught, c1. Two constants are there, right? Since it is discrete data, I can write sigma f of x minus what curve? What is the curve? C naught x plus c1 by root x. This one whole square. I have to minimize this. And one can write I here, I here, I here. Okay. Therefore, what we have for minimum, the necessary conditions we have dou I by dou c naught equal to 0. First one. Second one is what? Dou I by dou c1 equals to 0. Coming to first one, dou I by dou c naught. This is 2 into sigma. This f of xi as usual minus c naught xi minus c1 by root xi. And what is derivative with respect to c naught? What is c naught coefficient? Minus xi. So minus xi equal to 0, right? And coming to another one, this is implies this is 2 into summation f of xi minus c naught xi minus c1 by root xi. And what is the derivative of c1? Minus 1 by root xi equal to 0. Okay. After simplification means what? Keep fi terms onto the left side. After multiplication, take all other terms onto the right side. Therefore, the normal equations for the given curve are first one, summation. Left side is what? Xi into f of xi equal to c naught into summation xi square plus c1 into summation root x comes to numerator. First one. Coming to second one, this is 1 by f of xi by root x. F of xi by root xi equal to c naught into this becomes root xi, right? And plus c1 into root x, 1 by root xi into 1 by root xi, what? 1 by xi. These are the normal equations, isn't it? Right? After simplification, you will get this. One can write this as root x power 1 by 2 means root. Now, so form the table for the required values. For the x values given 0.2, 0.3, 0.5, 1, 2. F values 16, 14, 11, 6, 3. Okay, what is sigma? Okay, no need of this. Sigma x. What are the required values? X square is required, root x is required, x into f required, right? Next f by root x is required. Next 1 by x is required. All these values are required. You compute all these values, okay, using calculator. Compute all these values. Now I will give the summation values. First one, sigma, I need x square and I don't need x square. Root x value is required. Sigma root x is 4.1163 and sigma xf value 24.9. Next one, xi square value, x square value 5.38. Sigma 1 by x value 11.8333 and f by root x value, sigma f by root x value 85.0151. Therefore, what is normal equations? Normal equations becomes 5.38 sigma xi into fi 24.9 na? Okay, 24.9 equal to 5.38 C naught plus 4.1163 C1. Next expression, 85.0151 equal to 4.1163 C naught plus 11.8333 C1. So solving C naught is equal to minus 1.1836, C1 equal to 7.5961. Therefore the approximation is f of x equal to 7.5961 by this is x square root x and c naught minus 1.1836x. This is the approximation. And what is another question is given? Least squares error. Least squares error equal to what? Summation the function value f of xi minus this one. What is this? Minus c naught xi minus c1 by xi root xi. This whole square is the value, right? So this is I equal to from where to where? 0 to n. So one can write, already c naught is known, so summation I equal to 0 to how many values? 1 2 3 4 5. 0 1 2 3 4, 0 to 4. This f of xi and the c naught value is what? This is minus means 1.1836 xi minus 7.5961 by root xi, this whole square. So how to write this? This is equal to first f of x naught minus 1.1836 x naught 7.5961 by root x naught whole square plus same thing with x1 whole square, x2 whole square, x3 whole square, x4 whole square. Data is given. In the data, what is the data? X versus f is given, x0, x1 up to x4 and corresponding f0, f1 up to f4. The values are given in the table. After simplification, you will get the error as 1.6887. 1.6887. This is one model. Now the last problem. The following values, the data is the following values of a function of the variable t are t versus f, 0.1, 0.2, 0.3, 0.4, and the corresponding function values 0.76, 0.58, 0.44, 0.35. Question is, obtain a least square fit of the form f equal to a into e to the power of minus 3t plus b into e to the power of minus 2t. Solution given what is the fit, what is the curve is given as f of t equal to a into e to the power of minus 3t plus b into e to the power of minus 2t. So using least square principle, we have what are the constants in terms of c0 and c1 given as this, okay, and what are the values of this t, the function one can write like this, f of t minus a into e to the power of minus 3t minus b into e to the power of minus 2t whole square, right? And one can write ti I is from where to where, I equal to 1 2 3 4, so one can write I equal to 1 to 4 or 0 to 3, okay. This is the function. For minimum or to minimize I, the necessary conditions are what is the first one, dou I by first unknown a and second unknown dou I by dou b equal to 0. So what is the first equation, 2 into summation I equal to 1 to 4 the function f of t I minus a into e to the power of minus 3ti b into e to the power of minus 2ti, and what is the derivative of a, minus e to the power of minus 3ti equal to 0. And the second expression, 2 into summation I equal to 1 to 4 f of ti minus a into e to the power of minus 3ti b into e to the power of minus 2ti, and what is the b derivative, its quotient minus e to the power of minus 2ti equal to 0. After simplification, what I'm getting after simplification, oh, this is summation I equal to 1 to 4 f of ti e to the power of minus 3ti equal to summation, this is a into e to the power of minus 6ti you will get, plus b into summation e to the power of minus 5ti. This is I equal to 1 to 4, I equal to 1 to 4. This is the first normal equation. And the second one is, and summation I equal to 1 to 4 f of ti into e to the power of minus 2ti a into summation e to the power of minus 5ti plus b into summation e to the power of minus 4ti. These two are normal equations for the given curve, right? Now let us find all these values using table, substituting all these values, you know, t values. If I want to find f t, what are the required values, e to the power of minus 3t, right? E to the power of minus 2t is also required, e to the power of minus 4t is required, minus 5t is required, 6t is required. Both all these values required, and another one e to the power of minus 2t into f required, e to the power of minus 3t into f required. Okay, this is 0.1, 0.2, 0.3, 0.4. F values 0.76, 0.58, 0.44, 0.35, and you find all these values corresponding to each t. Okay, just I'm giving direct equations, substituting this in this normal equations. Okay, last step, substituting all the values, substituting the values in normal equations. We have 1.106023a plus 1.332876b equal to 1.165642. First normal equation. Second one, 1.332876a plus 1.622740b equal to 1.409764. So solving, we are getting a equal to 0.6853 and b equal to 0.3058. Therefore the best fit is f of t equal to 0.6853 e to the power of minus 3t plus 0.3058 e to the power of minus 2t. Okay, these are the problems based on least square approximation. With this, your third unit is finished.